After seeing these videos, you will be able to understand the welding process. What is the meaning of welding? What are the advantages of welding compared to other manufacturing methods, etc. You will learn.
This welding rod fits into an electrode holder, which is insulated and allows the operator to safely hold the electrode without danger of receiving an electric shock. The rod can be positioned in the holder in a number of different ways, depending on operator preference or the position of the work being welded. When the welding machine is on and the ground clip is connected to the steel table or to the work itself, anything metal on this table is now charged. When the electrode makes contact with the work, it completes a circuit. The electricity flowing through the electrode holder, down through the work, and back out through the ground clamp, back to the welder. When an arc is struck, a common pool of molten metal is created between the two pieces that are being joined. Into this, the melting alloy center of the welding rod is deposited, completing the weld. One thing to be careful of, as you're welding, this rod is being consumed. That is, it's growing shorter. So that the operator has to constantly be aware of both moving the rod laterally, but also pushing the rod into the seam being welded. The first step in learning how to arc weld is learning how to strike the arc. Striking the arc can sometimes be very difficult at first. It's a delicate flicking motion. It's not a stabbing or a quick drag, but as if you're striking a match gently. Once the arc is started, the trick is to maintain a nice smooth molten puddle of metal with a consistent distance between the tip of the welding rod and the surface of the work. Alright, let's give it a try. Welding hoods down. Remember, never look at an arc with the naked eye.
This is called arc welding. That is electric arc. Due to high electric current, that arc is produced.
Now that you've mastered striking the arc, and it may have taken you several tries, don't be discouraged. Let's join some metal together. Okay, hoods down. After striking the arc, I create a nice even pool of molten metal. You'll notice that the tip of the welding rod stays very near to the arc puddle, and I'm also slightly wavering the tip of the electrode back and forth.
Temperature at that point is about 3000 to 4000 degrees centigrade.
As the fillet rod is being deposited. Once you've completed your arc welded seam, you'll notice that there's a blue-black residue on top of the weld. This residue is a byproduct of the burnt flux. It needs to be cleaned away from the weld. You can do this with a chipping hammer. And
this
wire brush.
After welding, it has to be cleaned like this. So this is about arc welding. And I will show one more to make you understand gas welding. After that, we will go to the topic.
Hey, welcome to the shop. Today I'm going to be going over
This is gas welding. For very thin material, thickness is less, sheet metal and all. For that purpose, we use gas welding.
Hi everyone, today we're going to talk acetylene welding. Show you how to set up and clean it. Acetylene for oxygen or up you go. Don't ask me why, but it's going to help you remember every single step.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
So before I get started setting up my tanks, I need to make sure that my torch and everything has been set up correctly. We need to make sure that the tip, here, we need to make sure that the tip is clean. We need to make sure the tip is clean. If you do need to clean it, and you can tell once you actually start welding, you can use the tip cleaner. Tip cleaners look something like this.
This is welding torch.
First, we're going to do the settling first. We're going to open up the main valve here half a turn. So this, when I start, I want it to get here. And then draw a little line. Half a turn. Now, the last person who used this did not purge the valves. But usually when you get to it, you purge that valve for a second. Pressure on my regulator. Nope. This is basically how much fuel is left in the cylinder. And this is how much pressure will be coming through. So in order for me to increase pressure coming out of my torch, I'm going to have to adjust the regulator. I'm going to open up the knob on my torch handle for the acetylene or the fuel. Just open it up. Don't worry about how big it is yet. I'm going to adjust the regulator here. Going in plus or minus. Going to plus. And I'm going to increase it to about 6 psi. There we go, we're at 3, 4, 5, 6. You look very closely there. And you can hear acetylene action coming out. Go ahead and turn off your knob. This one is set and ready to go. Next we have our oxygen tank. We need to adjust this till we have between, I'm going to say 5 and 10 psi coming out of this. We're going to open this valve all the way until it stops. We're going to take our torch handle, open up the oxygen, adjust the regulator until we have between 8 and 10 psi. Hard to see the numbers, but we just need that little valve. Just a little bit right there.
This is oxygen cylinder.
So if you look closely, you can see that the valve on the left is just open a little bit. Down on.
When the combined, it is acetylene and oxygen cylinder, both are connected, and then it is started burning. It produces the flame. That flame, it is of 3 types.
Now, if you look at it, it looks like we have 2 different cones here. We've got a very light one. We have a longer one. Don't try to touch it, but you can get pretty close without the flame. I'm not going to purposely do that though. Alright, I'm going to adjust some more oxygen to that one cone at a time. Here's just like set the exposure on the camera down a little bit.
See the flame, how it is coming.
Acetylene, got that. Add your oxygen. There's 2 different colored flames that should come out.
By adjusting the oxygen and acetylene gas, we are getting different type of flames.
Great, let's get some love. So I have my flat bar set up with a very slight gap in between. I want to have a little bit of a gap to allow the metal to penetrate when it gets welded together. I'm going to start by tacking both ends, and then I'm going to do a fusion weld. The tack first. Heat it up and hold my torch on about a 45-degree angle, kind of zigzag between the 2 pieces. We'll concentrate on one area. If this is taking too long, increase the pressure to 1. What we're looking for is both pieces of metal basically turn molten. You'll see it start to get shiny on both sides, and then those 2 shiny parts will join together into one part. Back and forth. There we have now a little puddle. I'm going to do the same thing to the other side. I've dropped the exposure on the cameras to get a better look at what's going on here. So I'm holding my torch on about a 45-degree angle, zigzagging back and forth between the 2 pieces. I'll hold it towards the other side so you can see better. I want to get a nice little puddle going. Back and forth between the two. I'm just hovering above the metal. I don't want the torch to actually touch the metal. There's my puddle. Should join soon. The two sides are getting molten. I want those two little puddles there to become one. Wait for that moment. Little circles or zigzags. There it is. See that? Now we have a nice little joint. Now that I got my two sides tacked, I'm going to practice laying a fusion weld, which is basically taking that puddle, pushing it down the length of my joint here. Whether you're left-handed or right-handed, it doesn't matter. You've got to find a way that works for you. I'm going to go in this direction and push my puddle. So it's getting shiny. Wait for that puddle to join. There it is. Weld. Turn off using the acetylene.
So you have seen now the different welding techniques. One welding robot you have seen, and second one I had shown the gas welding, and one more arc welding, electric arc welding. These three types. One is actually two types only we have seen. One is arc welding and the other one is gas welding. So one more thing is advanced machinery, advanced machine tool, that is called as welding robot, that you have seen in this. So now after having seen these things, now let us try to go to understand, study about the, or in brief, let us go to discuss about structure welding. So now welding process.
Excuse me, sir.
Yes, please.
Sir, what's the composition of, in gas welding, what's the composition of gases, sir?
Actually,
I mean, you said that. Okay.
Yeah,
okay.
Yeah. There are three types of welding flames will come.
Okay.
Three types of welding flames are there. One is oxidizing flame. Oxidizing flame means there more percentage of oxygen, less percentage of acetylene gas. Okay. Two gases we have to mix. So more percentage of oxygen, less percentage of acetylene, it will give you an oxidizing flame, so that it the outcome is short flame. All these things you will study once again. So short flame you will get. One more thing, when more percentage of acetylene, less percentage of oxygen, then you will get oxidizing flame. Sorry, reduction flame. It is called as reduction flame. That is, more acetylene will be there, less oxygen will be there. The length of the flame will be long in that case. Flame length will be longer. One more type of flame, equal percentage of oxygen and acetylene. It is called neutral flame. Okay. Neutral flame means in oxidizing flame what happens, more amount of oxygen particles will be released after combustion. In reducing flame, more acetylene is there, so therefore more carbon monoxide and carbon dioxide output will come after flame. Okay. In neutral flame, it is just neutral because all the acetylene flame is burnt, all the particles will be burnt with the help of, by taking the oxygen particles, so that at the end of that it is neutral. It is not going to produce any effect. So therefore, while welding steel, different type of flame is used. While welding copper, different type of flame is used. So like that, we are using acetylene flame also for some purpose. Welding of hardening of steel, flame hardening is there. Like the different techniques, different welding flames are used for different purposes. Karthikeya, got it?
Yes, sir. Clear, clear, sir. Got it, sir. Got it. Thank you.
So now we have seen different welding techniques. Meantime, now we are going to discuss about this topic. Here in this chapter, we are going to study about module 4, welding process, definition of welding, what is the meaning of welding, principles of welding, types of welding, classification, and applications of welding, where the applications, what are the different uses like that, and what are the advantages and disadvantages of different types of welding. For example, arc welding, gas welding. In arc welding itself, there are different varieties. Metal arc welding, shielded metal arc welding, gas welding. Here, TIG welding and MIG welding, two types are there. All these things are there in our TIG welding and MIG welding is there in our college. Okay, that also you can see. Arc welding is there. You can, if you practice all these things in our workshop, then definitely you will be able to understand the concepts more clearly rather than theoretically. Okay, theoretically we will be studying here. Also in the laboratory, you have to practice all these things. Whatever is available, you have to practice. One more type of welding is called as resistance welding. This is electrical welding. Okay, electrical welding. This also electrical welding only. Arc welding is also electrical welding, and resistance welding is also electrical welding only. So it is a method of producing the heat by means of electrical resistance. So that we will learn. And finally, the gas welding also will be there. Okay. And apart from that regular type of welding, we are going to learn about the laser welding, electron beam welding. So these two are, laser welding and electron beam welding, are non-conventional type of welding. And other types from here to here, they are conventional type of welding. Conventional means what? The welding practices, we are practicing it from old techniques type welding. So those are called conventional or traditional type of welding. And non-traditional type of welding, that is newer techniques, latest techniques, they are laser welding and electron beam welding. We will be studying about those topics also in this chapter. Next, if you come to module 5, we will be studying about the metallurgical aspects in welding. So metallurgical aspects in welding means what happens when high heat is supplied. I told you the temperature at the junction of welding, the temperature is 4,000, 5,000 degrees centigrade. Even sometimes big thicker material, it will reach up to 10,000 degrees centigrade. Very instantly, it will not be there for long time. Very instant, short period of time, short distance, it will be, temperature will be very, very high. And immediately from that 5,000 degrees centigrade, room temperature, it will acquire it, or it will come back to room temperature very short period of time. During this heating and cooling within short period of time, it will create a lot of metallurgical problems. So those things we'll be studying here, metallurgical aspects. Okay, what happens like that. And other method of joining is soldering and brazing. So other than welding, joining methods are soldering and brazing. These two methods are also there. We will be studying those things in this. I think better last class you will be